In this presentation, we're going to continue our study of geometry and look into volume of cubes and rectangular prisms. On this page, we're going to take a look at some formulas for finding volume for rectangular prisms and for cubes. Now, you might be thinking to yourself, volume, what is volume? Well, if you take a look at this rectangular prism, for example, if you imagine that this is a container and you need to fill it up, well, the capacity of this rectangular prism would be its volume. It's how much it can hold or how much space it takes up, really. So later on, for irregular shapes, you'll use displacement to find the volume of figures. So, well, for this one, the rectangular prism, we do have a formula for finding its capacity or volume, and that would be length times width times height. And if you look back to our study of area, we had a length and a width. So I'm going to write that right on there. This will be our length, and this will be our width, how wide it is. And the big difference and the big jump from going two-dimensional, like in area, like the surface of any surface of this rectangular prism. Of course, you'd have rectangles as surfaces and also squares on each end. But anyhow, when we're looking at area, or the surface of a rectangle, we're just using length times width. Well, now, the big difference and the big jump from 2D to 3D is height. So you have along here, we have a new dimension, and that would be its height. And when you multiply these three, you will find your volume measured in cubic units. Just like you have 3 dimensions, you have your units raised to the third power. So, in order to find volume for rectangular prisms, you multiply length times width times height. And I'm going to show you some examples of those and then give you a chance to solve some on your own. And on our second figure we're going to look at is our cubes. And the volume formula for cubes is really, you take the measure of a side and you cube that. And it's also written as side, the measure of the side raised to the third power. Just like squares, if you're given one side of a square, you can assume that the rest of the sides are the same length. And the same goes for cubes. If you know the measure of one side or one edge, it's going to be the same measure for the rest of the edges or sides on that cube. So in this case, we have 4 centimeters as the measure of one side. So let's kind of throw that in there. So we know that volume equals side cubed. So volume must equal 4 to the third power. What does that mean? Well, we did talk about that in our order of operations posts. And when you have a number raised to the third power, that's an exponent, and it just tells you that you want to multiply that number by itself the number of times shown in the exponent. So it would be 4 multiplied by itself 3 times, and that would be your volume. So we have to solve that. So we have to solve that. So 4 times 4 would equal 16, and 16 times 4. If you don't know that off the top of your head, you can just multiply it out. It's always good to show your work. So let's show 16 times 4. And we'll use the lattice method. And that was voted the most popular method for multiplying 2-digit numbers in on the blog. So let's go with that. So we set up our lattice is a 2-digit by 1-digit lattice, so it's a 2 by 1 kind of box setup or array or matrix setup. So here we go. We'll multiply 4 times 6. Let me change my pen so it shows up better. 4 times 6, you're probably thinking it's 24. Good for you. It is. So it's 4 times 6 is 24. Then you do 4 times 1, and that would equal 4 with 0 tens. And now you add up diagonally. That would be 4. 4 plus 2 is 6. If you want more information on how to do this lattice method, you can check out our posts on the 4 methods of multiplying multi-digit numbers. So here we go. We've got 16 times 4 is 20, or I'm sorry, 64. So our volume would equal 64, and our units were here, centimeters. So we'll just take that and raise it to the third power. We have 3 dimensions, so our units we're going to use are centimeters cubed, or cubic centimeters. You could say it either way, it means the same thing. So our capacity for this cubic container would be 64 little centimeter cubes. And if you can imagine here, we've got a centimeter cube. Each edge would be 1 centimeter in length, and it would take 64 of these to fill this container, this cubic container. Its capacity would be 64 centimeters cubed. Now let's move on, and we'll take a look at this example. How do you think back? We'll apply what we know, what we've learned. We know that volume equals length times width times height. You might see it written this way when there are no operation symbols between these letters that stand for length, width, and height, then you assume that you multiply. So that's what we're going to do. So we'll take our length, and our length is here, 8. So 8 times our width, and our width would be here. It's also, I mean, you could also look at this edge. It would be the same. 4 centimeters times the height of this container, this rectangular prism, would be 6. So there you have it. We can break this down kind of like we did in order of operations too. 8 times 4 is 32 times 6. We can multiply that out. 32 times 6. Oh, 2 digit by 1 digit. And my lattice got a little crooked there. Okay, so let's do it again. 32 times 6. All right, so we've got a 2 by 1 lattice. A little more straightforward there. And our diagonals coming down. 6 times 2 is 12. 6 times 3 is 18. 8 ones, 110. We add diagonally. 2, 9, because 1 plus 8 is 9, and then 1. So our volume would be, volume equals 192 centimeters, because we looked at our units here, centimeters raised to the third power. So 192 cubic centimeters. So you can imagine 192 of those cubes filling up this rectangular prism. Now here's an example of, but you can guess the figure. Only one measure is listed, and it must be a cube. So we've got a 3-dimensional figure with all sides the same length, must be a cube. So here we go. We'll apply our definition for volume of a cube. Volume equals side, or the measure of a side cubed. So volume must be 6 to the third power, which means 6 times 6 times 6, and we can multiply. So volume equals 6 times 6 is 36 times 6. Let's use the traditional method this time. 36 times 6. 6 times 6 is 36. 6 times 3 is 18, 19, 20, 21. So we have a volume of 216. And our unit this time was meters. So we have 216 meters cubed, or cubic meters. That's a pretty large cubic container. And let's move on to this next example. We'll do something a little different for this one. I'm going to let you try this on your own, or if you have a class and you want your class to try this, go ahead and pause the video now. Okay, so I'm going to move on to the next one, and I'll actually go over these problems afterwards. So go ahead and take a look at this one and pause the video. Give yourself some time to complete it. And move on to the third example. Pause the video. And last, we have a fourth example. And it looks like a combination of what we've learned so far. So apply what you know to solve this one. Pause the video now. Okay, let's go back through these. And you can check your work as I go through these. So this was example number 1. Hopefully you're thinking it's a rectangular prism, and it is, so good for you. So let's get that down. Our volume formula. Volume equals length times width times height. If you got that, good for you. Volume equals length. We'll take our 12 as our length, times our width of 5, times our height of 10 centimeters. And we'll multiply this out. 12 times 5, 12 times 5. All right, 5 times 2 is 10. 5 times 1 is 5. Add diagonally, and we've got 60. You may have known that if you know your 12 facts. Excellent, good for you. So we now have 12 times 5 was 60 times 10. All right, and you might be thinking, we learned this trick in our multiplying by powers of 10 post. If you take a look at the basic fact, you've got 6 times 1 equals 6, and then you can tack on your zeros. It's the handy thing about working with tens or powers of 10. Then we have our volume at 600, and our unit was centimeters, so we'll take centimeters to the third power, and we'll have 600 cubic centimeters would fill up this rectangular prism. And there's the solution to that. We'll move on to problem 2. And that was another rectangular prism, so we once again have the volume formula as volume equals length times width times height. Okay, so we've got volume, and we want to find the length. In this case, well, the height is 5. It's really the longest side, but happens to be how high the figure is. So we'll use our longest side down here. We have 3, and our width was 2, and our height was 5. So it'll give us 3 times 2 times 5. And now we can multiply these. 3 times 2 is 6, and 6 times 5. I bet you know what that is. 6 times 5, it's one of our basic facts, and that would be 30 centimeters cubed, or cubic centimeters. It would take 30 cubic centimeters to fill up this rectangular prism container. Its capacity would be 30 centimeters cubed. All right, example 3, we've got a cube, so automatically I'm thinking of my volume formula for a cube, and that would be volume equals the measure of a side to the third power. So volume must be 15 to the third power, or 15 times 15 times another 15. And let's see what that would be. Volume equals 15 times 15. 15 times 15. So it'll be a 2 by 2 lattice. Ooh, it looks like a kite. Anyways, well, 1 times 5 is 5. 0 tens. 1 times 1 is 1. 0 tens. 5 times 5 is 25. 5 times 1 is 5. Add diagonally, 5. 5 plus 2 is 7, plus 5 is 12. One more to that column. 1 plus 1 is 2. You can see how the places line up right there nicely in the lattice method. And our volume is not quite complete yet because we just multiplied the first part of it. So it's 225. So that came down like that. And we just have to multiply what we have left over here, the 15, multiplied by 15. So now we have 225 by 15. The lattice method, takes a little bit of setup, but once you get it set up, it really kind of flows nicely. So we have 1 times 5 would be 5. 1 times 2. 1 times 2 once more. Move down to the 5. 5 times 5, 25. 5 times 2 is 10. And 5 times 2 is 10. You can add them up. 5 plus nothing else would be 5. 5 plus 2 is 7. 2 plus 1 is 3. And 2 plus 1 is 3. So now you've got a number in the thousands. And our volume would be, I guess we could continue with this color. Volume equals 3,375. 7 there. 3,375. And our unit was centimeters. To the third power. So it would take 3,375 cubic centimeters to fill this container. And our last one, probably the most challenging one, was a combination of the two things we've learned today. So we have to take apart this figure, and if it didn't have this line, you'd kind of have to imagine it as being a rectangular prism up top, and a cube on the bottom. So let's do the volume formulas for both of these. So volume for this figure would be volume equals length times width times height. And volume for this figure would be the side down there, the 4 cubed. Well, let's do the calculating now. So we've got our formulas, and we'll just input these numbers in it. We wrote the formula over here. So volume equals 6 times 4 times 4. 6 times 4 times 4. So volume equals 24 times 4. And you can multiply that. Let's use traditional. Change things up a little bit. 24 times 4. 4 times 4 is 16. 2 times 4. 4 times 2 is 8. Plus 1 is 96. Alright, so the volume for the top portion, or the rectangular prism portion, would be 96. Whoa, got ahead of myself. Would be 96 centimeters cubed. And if you got to double check your unit, yep, centimeters is what we've been using for this figure. So now we know that this is 96 centimeters cubed, and this volume would be volume equals side squared. Our side measure would be 4 centimeters. I mean cubed, I should have said cubed. So excuse me there. Alright, so volume equals 4 times 4 times 4. That should sound a little familiar to you. So 4 times 4 we know is 16, and 16 times 4. If you're not sure, it's always great to show your work. So 16 times 4, 4 times 6 is 24. And 4 times 1 is 4 plus 2 would be 64. So the volume for the bottom portion, the cubic portion, would be 64 centimeters cubed. So that cube there, and we'll have our 64 centimeters cubed. And now we can add those two up. So we've got the 96 right there, and we have the 64 centimeters cubed. We've got to add those two together. Let's do that now. We use a different color ink, and we'll just use the space we have over here to show our work. So we have 96 plus 64. Add those together. 6 plus 4 is 10. Carry the 1. 9 plus 1 is 10 plus 6. We have 16, or for a total of 160 centimeters cubed. So our volume for this whole figure is 160 centimeters to the third power, or elevated to the third power, so it's cubic centimeters. It would take 160 cubic centimeters to fill this container. So there you have a quick look at volume of cubes and rectangular prisms. Thanks for checking out Mr. Marinick's EduBlog or the Marinick video channel on YouTube, and we'll see you again next time.